Thank you. All right. So I'm going to be talking about an aspect of streaming architectures that I'm actually most excited about, and that's events. And so you may have heard of some of this real-time technology. How many people out there are familiar with Apache Kafka in some way? Yeah, so a pretty good set. How many people are kind of actively using it? Yeah, some. So I'll talk a little bit about what I think this streaming area in Kafka is kind of ultimately about. I'm going to be talking about events and event data and event-driven systems. And the title of my talk, Overcome by Events, this is a military term, and it's used when a situation changes so rapidly that previously proposed courses of action are no longer relevant. And I think this is something that's happening with event data, where you're seeing it kind of spring up in all different types of systems. It's springing up in different types of architectures, and I'll highlight a few examples of that and kind of show how this is kind of coming to the forefront. So I'll start with just saying what is an event. So if this is a talk about events, what are events? So events are things that happen in the world, and event data is data about those things. And so that's all it is. It's so simple. We could probably end the talk there, right? Yeah, so an event is something that happens. It's something that happens in a business or an organization. It could be a sale. It could be an invoice. It could be a trade. It could be a customer experience. This is something that took place. And where are they? Well, events haven't really had a proper home in infrastructure. They've been kind of implicit. So obviously, there's many things happening in a business, but this isn't something that's been represented in data systems. It's not something that's really been represented in databases. It's not something that's really been talked about. But if you look at kind of some of the areas where this idea of events is showing up, it's showing up in a bunch of different types of systems. It's showing up in microservices. It's showing up in monitoring systems. It's showing up in data pipelines. It's showing up in analytics. And so I'll talk about these a little bit. I'll talk a little bit about some of the things in Kafka that help it support this type of event-oriented thinking. So let me go through some of these examples. So companies have been moving towards microservices architecture. This is kind of the big problem in software engineering. How can you apply more engineers and get more output faster, right? And most people know that as you add people to a project, you get a little more output, but it kind of tapers off. And in some sense, the solution to that problem must be to cut it up into pieces and let everybody move independently. That's what the solution to every problem in computer science is: divide it into modules, right? But how do these modules communicate? And a lot of the early microservices architectures were very much point-to-point communication over synchronous network communication. So something like REST, HTTP. These are synchronous communication. But a lot of people have found that when possible, it's really best to communicate with events, to actually publish, hey, this occurred, and allow back-end systems to react to that. And this doesn't solve every problem. A lot of synchronous front ends are still going to be synchronous and communicate over HTTP, but a lot of the back end of a business is not synchronous. The fulfillment of orders, the placement of trades, these are asynchronous activities. You want them to happen as quickly as possible, but you don't want it to time out and go away if it didn't happen right away. And so events have started to show up in microservices. And you can see this in the rise of serverless platforms. Like most people, when they focus on serverless, the focus has been on getting rid of the containers and getting rid of the servers. But at the heart of a lot of these systems is events and processing events and reacting to events. You can see this inside the services with event sourcing. So this is kind of a trend that's come around in microservices where you're actually representing what happened. You're representing the stream of events and you're storing that. And this is kind of taking that event orientation from being not just how the services communicate with each other, but right into the heart of how they model data. All right. So that was microservices. I'll switch to monitoring. So there's typically been kind of 4 pillars of monitoring. There's metrics and alerting and log aggregation, and maybe the new kid on the block is distributed tracing. But if you look at each of these, in some sense, all of them is really representing event data and event processing. So log aggregation, this is maybe the easiest to see. A log, after all, it's like a record of things that happened. And that data is ultimately event data. And so one of the things that's become possible is to be able to actually process that. If you look at metrics, this is ultimately some graph of what happened, right? But at the heart of what happened, this is some aggregation of the same events that we had in the log. So here is an example of a query in KSQL. And this is a streaming language for doing SQL on data streams for event processing. And this SQL query is actually computing a stream of metrics in real time off the raw events. You can think of alerting in the same way. So an alert, we would think of it as like, oh, I got a phone call, there was some kind of problem, or I got an email, some alert was triggered. But an alert is after all, it's some series of things has happened in the world that's triggered this kind of alert to occur. So you could think of an alert as being a type of stream of events in its own right. And finally, distributed tracing. This is the ability to actually trace across that big service graph I showed. You can think of this as also being a kind of join across all your different services events to actually stitch them together and get some kind of unified picture. So that's kind of the situation in the monitoring space. But events are showing up beyond that. So in data pipelines, in the movement of data in what we would traditionally call ETL, events have been showing up here as well. So the introduction talked about some of the challenges of actually unifying data across different systems. And the way we've traditionally done that is by kind of scraping data out of tables and munging on it and putting it into a new table. But another way to think about this is to actually treat the updates to these tables, to treat the things happening in application as a stream of events, and allow continuous processing on this and allow this to plug into the other systems that need a representation of that. And the advantage that this has is it's scalable. It can work across an organization. It's real time. It can be integrated into operational systems as well as analytical systems. And it's publish, subscribe. So one stream of events can go to many different consumers. And this idea of events is actually nothing new. So if you look at traditional data warehousing, right at the center of your data warehouse is probably a large fact table. And a fact table is very much a representation of event data. It's a list of things that happened. It's sorted by time. Now, unlike modern event streams, you can't necessarily subscribe to a fact table in real time, and you can't produce derived tables continuously as it updates. But a fact table is really nothing more than a type of stream of events. And so this idea of events is actually nothing new. Data warehouses have had it for a long time. They had it because they had to. If you want to be able to talk about what happened, if you want to be able to do analytics on what happened, you're ultimately talking about event data. And the reason that this is relevant is as analytics has moved from something that's purely about reporting to something that also has kind of machine-driven output, you start to see applications that are actually trying to create feedback loops directly. So instead of feedback going to some report that a human looks at and then makes a decision and emails somebody to take action on, you actually are closing that feedback loop where you have data coming in, you have some kind of machine learning process which is making a decision, and you have output and action being taken directly in software. Obviously, in that world where you're connecting computers to computers, it doesn't really make sense to have kind of a daily process that does the analysis in the middle. After all, who's to decide when the end of the day even is in a global business that has kind of continuous production of data? And so it makes much more sense to have a continuous stream of events where decisions are being made as quickly as they can right off of that stream. And this is a trend that we're seeing really commonly for these kind of machine learning applications that are tapping into many of these data streams to make decisions. And so I think the conclusion here is that events are kind of everywhere. They're actually happening across all these different domains of software. They're showing up in all these different systems. And it makes sense. In some sense, if you think about what is a business, it's ultimately about a series of events, the things that occur, and the reaction to those things. And yet somehow, we haven't really had much infrastructure for events. So this is, I think, a really fundamental concept. It shows up across all these systems, but it hasn't really been represented in databases it hasn't really had kind of a first-class home. So what we've actually had, traditionally there's no home for these. What we've actually had is tables, right? This is what databases give you. They give you kind of a fairly static view of your data, right? The goal of a table is to try and hide the change and the updates from the user. And this turns out to be important, right? You need tables. That's what the current state of the world is. The current state of the world is in the table. But these event streams are what's happening in the world. And that turns out to be almost as important, right? Like, any application is fundamentally reacting to what's happening in the world, and it's kind of updating the state of the world. And so these two things are really closely connected. Tables and events are closely connected. What's happening in the world impacts the state of the world, and the state of the world causes new things to happen. And so the challenge for applications is to be able to work with both this kind of state as well as events and do these things together. But this hasn't really traditionally been supported by databases. And this is something that shows up in these kind of modern stream processing architectures, is this duality between tables and streams. The idea that you could take changes from a database, the kind of change data capture stream, that you could react or transform that, and that you could publish out outputs, right? And turn that back into some kind of table. So in some sense, your table is turning into a stream of events. You're processing that stream of events and driving new action, and that's going out and becoming more tables in its own right. And this idea of orienting around streams, this is the idea of a streaming platform. And this is what Apache Kafka is meant to do. And it's meant to be able to scale organization-wide and connect all these different things: monitoring applications, microservices, different applications, real-time analytics systems, and different data systems, and really orient all these different systems around streams of data. This can be kind of the interchange that these things connect on, that they communicate over. And I'll talk about a few key elements of Kafka that help it do that help make it effective for event streams. So the first is, it's really built around this concept of a kind of continuous commit log. This is really the data structure for a stream. It's a series of records that occur. Each of these records can have many readers, and you can subscribe kind of in real time as this happens. So this stream of records, it could be the sales happening in a business. It could be the updates to your kind of core customer data. Each of these is occurring in real time, and any number of things can tap into that and subscribe to it and process it. So that's the first aspect. The second is Kafka actually has deep support for table data, right? And treating that as a type of special event stream. So if you tap into a database and you publish out the list of changes to some customer table, you can treat that as an event stream. It'll maintain that in a special way. It'll compact it down and not throw away the old updates. And this allows stream processing that can work across both tables of data and streams of data, both in the same system. And you can get real semantics on top of that. Next up, it's horizontally scalable. And this is important not just because you may have some applications which are large, but also because the goal for this type of streaming platform is to go between things. And you want to be able to connect up more and more things. So you can go from one application to something that really works across a whole organization. And you can do that gradually, one thing at a time, as it makes sense to do it. And then finally, Kafka supports a connector architecture which allows you to run different plugins for different data systems. So if you want to be able to capture streams of changes from some data system, or you want to be able to load a stream out into some data system, there's hundreds of these off-the-shelf connectors that can be run. All of these connectors are fault-tolerant. They're horizontally scalable. And you can kind of manage them all independently. So you can actually scale this up in terms of how many things are connected. And then finally, Kafka has really deep semantics for transactional processing on data streams. And this is really important for getting the right answer. So I talked about being able to put together tables of data with streams of events and do processing on top of that. All of that's only useful if you can give strong guarantees on what the output's going to be. And one of the things that's held back this area of real-time processing is it traditionally hasn't been able to give the same guarantees batch processes gave. Batch processes were easy to reason about because either they ran, in which case you got the right answer, or they crashed, in which case you didn't get any answer. Either way, you kind of know what's coming out. A continuous real-time process is actually harder. And so really at the heart of Kafka, all the way from the storage layer up through the protocol, is this ability to do transactional processing in a really rich distributed way. So you can read input streams, you can do transformations, even stateful transformations like counting things or joining together streams of data, and you can write output. So in those KSQL examples I was giving, those are stream processing examples on top of data streams. Those can be made transactionally correct simply by enabling this kind of transactional processing. And then beyond the technical things, what's made Kafka successful, I think it's just the community and the ecosystem. So there's tens of thousands of integrations out there. There's connectors. There's hundreds of meetup groups. There's a good meetup group here in London. And that kind of community is all the code that you don't have to write, right? This is all the tutorials, the books, the off-the-shelf connectors. This is what makes adopting something like this plausible. You're not going to go rebuild all of your organization around this, but if you can get a lot of that off the shelf, if you can get processing layers that make it easy to build applications and connectors for the systems you have, it can make it much easier to get into something like this. And this is what has made this architecture start to take off in the world. And we're starting to see this show up at, really at the heart of some of the largest banks in the world, large insurance companies. There's stock exchanges running off of stream processing in hospitals. Really amazing use cases in every industry you could imagine. And that's it. Thank you so much.